Picking up where we left off, we're going to start with part C. Once again, we're trying to use the square root property in order to solve, and the first step is to isolate the term that's being squared. So here I'd have to add 20 to each side, meaning I have 4x squared equals 25. X squared is still not by itself, so I need to divide each side by 4. That gives me x squared equals 25 fourths. In order to get x by itself, I need to take the square root of each side, and whenever I take the square root, I need to put plus or minus out front. So I have plus or minus the square root of 25 over 4. Now we're going to use something called quotient property. So product property, we can split it up. Quotient property, we can also split it up. So I have the square root of 25 over the square root of 4. Well, the square root of 5, let's simplify here. The square root of 5 is just 5. The square root of 4 is just 2. So I have two solutions, a positive 5 halves and a negative 5 halves. All right, part D. Once again, the first step is to isolate the term that's being squared. The term that's being squared here is the x minus 3. So I need to isolate this parenthesis. You must add the 8 first and then divide by the 2. Okay, so I'm going to add the 8 first to each side. I have 2. X minus 3 squared equals 8. Okay, now I'm going to divide by 2. So I have x minus 3 being squared equals 4. Okay, so now that I've isolated the term that's being squared, I haven't solved for x yet, but I've isolated this, I can take the square root at this point. When I take the square root of x minus 3 squared, the square root and the square cancel each other out. So I just have x minus 3 equals plus or minus 2. Because I took the square root, I have to put plus or minus 2. But x still isn't by itself, okay? Now I have to add 3 to each side. So if I add 3 to each side, I have x equals plus or minus 2 plus 3. So really, my two solutions will be a positive 2 plus 3 and a negative 2 plus 3. So my answers would be 5 and 1. Our second objective for today's notes was completing the square. So this is just an introduction. It's very, very basic, and we're going to go more in depth and actually solve by completing the square in our next class. So just a little bit of history. The person who found how to complete the square or developed this method was named Muhammad ibn Musa al-Khwarizmi. That's probably the best you're going to get out of me. And quadratic means square. So he used tiles to create a square and quite literally completed the square using this method. So you'll see what I'm talking about when I draw a diagram here in a second. Now, algebraically, that means in order to complete the square for something written in the form x squared plus bx, we would need to add b over 2 being squared. So it must be in this form, x squared plus bx, in order for us to complete the square, meaning a must equal 1. So I'm going to write that. A should equal 1 if we're going to be completing the square. All right, so I'm going to show you how Muhammad would have completed the square. Again, this is using algebra tiles. So he had big tiles that represented x squared. where each length was x. So this length was x, this length was x, and this would be x squared because x times x is x squared. He's using area. He would use rectangular tiles with a length of 1 and x to represent x because area, 1 times x is x, and little tiny squares that represented 1 because their lengths were 1 times 1. So if I have x squared plus 4x, he'd say, okay, here's my x squared tiled. I only have one of those, and I have 4 x tiles, so 4 of these. Now I'm trying to create a rectangle, I'm trying to create a square, not a rectangle, so I'm not going to put all 4 x tiles on one side. Instead, what I'm going to do is I'm going to put 1, 2 here, and 1, 2 here. So now the question is, how many of those little tiles, the 1 tiles, would I have to add to complete this square that I've created? Well, 1, 2, 3, 4 of them. So really, I would have to add 4 ones. And if I were to write this as a binomial, which you're going to see me doing later on, it would be x plus 2 and x plus 2. He got this by looking at the lengths. So this length is x, these lengths are 1, so 1 plus 1 is 2, length of x, and then 1 plus 1 is 2. If I were to FOIL this out, like we did in the warm-up, x plus 2 being squared, so x plus 2x plus 2. If I FOIL that out, I have x squared plus 2x plus 2x plus 4, or x squared plus 4x plus 4, which, see, that gets me back here. All right, so example 3, I'm going to complete the square. Instead of doing the diagram, because I think that gets a bit confusing for you guys, I just wanted to show you how Muhammad would have done it, how he discovered the method. I'm just going to talk about the algebra and the numbers, okay? Because this I think, like I said, is a lot easier than having to use the tiles. So algebraically, what we're doing here is we must have something in the form x squared plus bx, where a is 1 and b could be any number, positive or negative. Now we're going to add some number, essentially completing the square, okay? Whatever number we add will make it so I can write it as a perfect square. That number just so happens to be b divided by 2 squared. So I'm going to add b divided by 2 being square, but when I plug it into my perfect square, it's just plus b over 2. All right, let's see this happening with numbers. It'll make it a little bit easier to understand. So what I have here is I have x squared plus 6x plus something. I have to find out what that c is, what that number is going to be. So I'm going to use the equation b over 2 being squared. B is this number right here. I have a positive 6. So I have a positive 6 over 2 being squared. Well, 6 divided by 2 is 3. So I have 3 squared, and 3 squared is 9. So what I really have is x squared plus 6x plus 9. By adding the 9, we've made it so we can write it as a perfect square binomial. And that binomial would be x, and then whatever was inside of the parentheses up here, the b over 2. So 6 over 2 was 3, so I'll put plus 3. Okay? Let's try example 4, where we're completing the square once again. Same thing. I have x squared minus 2x plus some number. That number will be b over 2 being squared. B in this case is a negative 2, so I need to keep that sign with it. Negative 2 divided by 2 being squared. Well, negative 2 over 2 is a negative 1 being squared. Negative 1 squared, that's negative 1 times negative 1, so a positive 1. So x squared minus 2x plus 1 can be written as a perfect binomial, where it would be x plus your b over 2. So this time my b was over 2 was negative. So I need to put minus 1. X minus 1. And notice, if I were to FOIL this out, it would bring me right back here. That's a way you can check your work, is by FOILing this out, you should get a trinomial that we wrote here by adding the number. All right, one more, part B. B over 2 squared is how I'm going to find the number. So my b was 5 over 2 being squared. Well, that would be 25 over 4. Because 5 squared is 25, 2 squared is 4, I distributed the square, meaning I now have x squared plus 5x plus 25 over 4. I wanted to show you it's not always going to work out perfectly. You may have fractions, and if you do, it's still the same process. So I can rewrite this as a perfect square binomial, and it would be x plus your b over 2. So my b over 2 was 5 halves. So I'll put plus 5 halves.